All right. Hello, everybody. How's everyone doing? Sorry, I was a little late. Didn't let somebody with a jacket in a DevOps session, but somehow I made it. I'm so glad to be here, finally, after 2-3 years of doing a lot of these things virtually, being in person, talking to people, meeting real customers, developers. It's been a fun and exciting last couple of days, let me put it that way. My name is Ankur. I run the cloud security business at Palo Alto Networks. The platform, the product's called Prisma Cloud. We're going to speak less about marketing and the product, but more about DevSecOps. I've been doing this for 5 years now, helping customers secure their journey to the cloud early on in the pipeline, middle stages, runtime, whatever that may be. My co-presenter, Guy, he was ready to fly on Friday. He was coming from Israel. But as you all know, this new variant, Omicron, hit the humanity, and he had to shut down his plans. But I'll be able to cover the whole thing. Before we get started, kind of show of hands, and I know it's hard to see, how many of you in the audience are kind of have DevOps responsibilities? Okay, looks like about half. How about the folks who do security exclusively? Okay, good chunk. And how about the folks who do both, DevSecOps? Okay, perfect. So you're in the right session. Rest of the folks can go out. So, your world, if you've been doing DevOps, you've been doing security, you've been doing DevSecOps, has changed significantly over the last couple of years. All the trends that we knew were happening have all been accelerated significantly. Your developers want to move fast. Everybody is doing digital transformation. They want application to be shipped every day from once a year or once in 6 months. And a lot of the customers, and you are struggling to figure out what is the best way to secure your journey to the cloud. What is the best way to allow developers to move at cloud speed without breaking things, without leaving your critical infrastructure, your applications, and your crown jewels vulnerable to attacks. This is what I'm going to talk about. We've spent a lot of time in the industry, and we'll focus on that. So, this is might as well be a slide from 5 years old. We all know this cloud security is a shared responsibility model. I think the statistic that really spoke to me was the fact that by 2024, 70% of the cloud workloads, or 70% of the workloads will be in the cloud. 70%. All the transformation that we knew were happening is happening at a really, really rapid clip. And this is what I call the wave 3 of digital transformation. Wave 1 was all about SaaS, et cetera. And when we had a SaaS application, and prior to running public cloud security, I did SaaS security. What is the only thing you have to worry about while protecting commercial SaaS application like Salesforce, et cetera? What is the one and only thing that you have to worry about? Data, right? You don't care where Salesforce is hosting their stuff. You don't care about anything else. The only thing that you have to worry about is the data. Now, public clouds changed everything. You have to worry about everything. Infrastructure, Kubernetes, misconfiguration, the data that sits in there, applications, serverless. I mean, the workload types have significantly expanded over the just last 3 years ago. Like 6 years ago, like containers and Kubernetes were not even mainstream. Now it's like every customer you talk to has that. So the responsibility of the security teams and the DevOps team has significantly increased and in this sort of new world order. But just like cloud security is a shared responsibility model, so it code to cloud. So when you build your application from early stages, from your ID to SCM to runtime, it's a shared responsibility between dev and ops team. Now, this is a slide that nicely puts the responsibility between dev and ops in 2 buckets. How many in this room actually believe that these roles and responsibilities are as cut and dry? Nobody. Because the reality is that the real world is very, very difficult. Under what circumstances should a developer own the security? Should they worry about the code security part of it, the open source scanning and vulnerability part of it? Should the traditional security just worry about the network security and data security, things that they have been doing for many, many years? It's not very clear, right? We understand that it's a shared responsibility model where the centralized security teams have to enable the DevOps to use more and more security, but it's not as cut and dry. I always ask this question to my own VP of engineering. I say, if your cloud account were to get compromised and used for crypto miner, and if 2 pages went out, one to the centralized CISO security team and one to DevOps, who's going to wake up first? The chances are it's the head of engineering that's going to wake up first. Like, holy cow, what just happened, right? So the real world is complicated, and this is the struggle when I talk to customers, and we've talked to hundreds of customers where it's not very clear who owns what in this cloud world order, as much as we'd like to put things in these two nicely formed buckets. So the result of this is there's a lot of friction between the two teams. The developers are like, I don't know, I don't want to listen to the security folks at all. They're slowing me down. I was talking to a customer who actually literally showed this, and this is the DevOps team. They handed me a 400-page PDF report that their SaaS tool produced, 400-page report. Nobody in this room believes that the way to secure an application in today's cloud-native environment is to run through a 400-page PDF report, right? The developers are like, I'm just not going to pay attention to this. I don't care. This is too much friction for me. The securities problem right now, the way we see this, is that they have no idea how many cloud accounts get spun up, in GCP, in AWS, Azure. Where are the misconfigurations? Are developers deploying vulnerable images in runtime? Are their repos clean? Right? They have no idea. They have no visibility. And the moment they try to talk to DevOps, they're like, yeah, just go away. Like I don't have time for you, right? So there is that friction that both of these teams have been facing for a significant amount of time in our industry, and that has led to a lot of the challenges that we see, the supply chain attacks, the crypto miners. There is the stuff that you hear in the public, on the public internet, but there's a lot of stuff that happens that doesn't even make it way into the news. Because of these constant problems between the two teams. 71% of the developers, this is a good stat from GitLab, of the developers feel fully responsible or partially responsible for security, but only 49% feel that they have the ownership. Who in this room has read the famous Amazon book? It just recently came out called Working Backwards. Okay, if you haven't, a must read, not just because this is an AWS conference, but they talk about the inner working at Amazon. What makes Amazon Amazon, the biggest, the largest startup ever, allows them to move fast. One of the concepts in the book that they talk about is called single-threaded leadership. Everything Amazon does, there is a single-threaded leader. The problem is, in this particular case, in security, there is no single-threaded leader. It's a shared responsibility, so nobody knows like who's responsible for this. So while developers feel like they got to do something about it, they're like, is it my thing or is it a security thing? How do you know about it, right? So this is the problem that we see in our industry. One of the last things I'll talk about in the spirit of what are some of the key challenges that we see in public cloud security is sort of this whole manual and reactive way to solve and fix problems simply don't work. So let me give you an example. You've got a Terraform template or a CFT. Pick your favorite IAC. Somebody says, spin up 100 VMs, attach a security group that has zeros on ingress, ACL, launch 1,000 S3 bucket, make them all public, and launch this. Now all you've done is created 100 VMs and 1,000 S3 bucket, 1,100 assets that have problems. One mistake led to 1,100 different type of problems, right? There is no way to manually fix that problem. Like if you take a whack-a-mole approach and just go and look at all VMs that have that security group attached, one or more, fix those problems, and then go ahead and like one at a time, Fix the S3 bucket that's open to public. It simply does not work. You got to figure out a way to fix the root cause of the problem. Same thing, same example goes to vulnerability. Like if you've got a bad image with a critical CVE that is exploitable, if it gets deployed in runtime, now you can potentially spin up hundreds of containers running right now where some exploit is just waiting to happen. Unless you fix that image right there in your repo, that problem is going to magnify. And in a manual way to patch every host, it just simply doesn't work. Cloud workloads are cattle, not pets. You got to fix the root cause of the problem, redeploy the entire infrastructure, redeploy the containers. That's the right way to do it. Manual patching way is not the way to go. And when you add up all of these problems, and Gartner said that 99% of the cloud breaches will have a root cause that is preventable mistakes, right? And we see this internally quite a bit. What you hear about with the supply chain attack or major breaches at some of the largest fintech companies, is some sophisticated attack. I'm here to tell you that 90% of what we see is just simple problems. Permissive bucket, secrets in SCM, source code repo, a vulnerable image somewhere sitting in the runtime that somebody's trying to exploit, a misconfiguration. Somebody attaches a security group to a VM in a public VPC. It's a routable stuff. It takes, because the IPs are well known and public, it takes some attacker no more than 2 minutes to start sending SSH brute force or other types of attacks. They're going to start doing port scan and port sweep. Most of these problems are preventable. And if customers can take care of that, I think you're going to see less and less of these security incidents that we see. So what's the solution? We talked about the problem. We talked about what are some of the challenges. Full DevSecOps with bidirectional feedback is one of the ways to do it. And this is what I've seen personally successfully work in a lot of customer environment, right? And the idea here is that when the developers are in their IDE, I do an import. Back in the days when I was a developer, it was basically 80% my code and 20% open source library. The developers have gone a little lazy nowadays. It's 80% open source nowadays, 20% code. So when a developer says import foo.jar, scan it for vulnerability immediately in their IDE, right? So scanning that for vulnerability immediately. Once that package is built, and let's just say somebody in DevOps or development team says, okay, well, I'm ready to deploy this using my infrastructure as code, scan the infrastructure as code early on, right? Maybe it's the dev stage, maybe it's the QA. Like, why should QA only be testing the product, not doing the security checks? I don't know a lot of organizations nowadays where the QA team's job is not to look for security gaps. They should, right? They find a vulnerability, they find a misconfiguration. If you can highlight the problems where the developers and your teams are, it's going to be much easier there. Once it moves that pipeline, the code goes to your source code repo. Somebody should be checking there, right? Like whether it's a head of engineering. Like, hey, I've got my code, I've got the packages, what are the known vulnerability? Scan the entire repo for all your infrastructure as code templates, figure out what the problems are, and make sure if you have problems, it doesn't go in your CI/CD pipeline, whether you're using Circle CI, Jenkins, whatever you have, make sure it doesn't happen, right? But in spite of all of your attempts, let's just say the DevOps team, or IT or Ops, whatever you want to call it, deploys the infrastructure. You need a feedback loop back to the dev team. And that's where the right side of the chart sort of comes into play, which is basically the infrastructure is now deployed. You got to have a continuous monitoring process. Because I do not know a single customer, and this is born in the cloud customers, high-tech companies who are 100% cloud, who have everything fully automated. ISE, all they do is detect drifts. They understand what their goal state looks like, and all they're doing is detecting drift. Because customers have multiple applications, some of them are legacy, cloud native. Even within cloud native, not everything is 100% automated. So you do need a continuous feedback loop where once DevOps and somebody deploys the infrastructure, you can feed back into the dev process where you can say, hey, look, somebody left a security group overly permissive. Let's figure out and trace it back to where the infrastructure is code that led to that problem. Go back and fix that problem. Hey, I see hundreds of images right now in a running environment that have a known vulnerability, or hundreds of containers. What's the image that led to all of these problems, right? Is it the one image with, Alpine DB with curl, right? Like 22 million developers downloaded that, right? Like is that the one? Or do we need to fix other problems? But feed it back into the dev process. And that's why the handshake between whether you're DevOps and developers or security and developers, because the right side of the chart in today's world is not just ops, it's actually security teams, right? Like the whole thing gets deployed, security is using some tool to continuously monitor the runtime for advanced threats like crypto miner, command and control traffic, port scan, port sweep. But going back to the development team, and closing that feedback loop is the best way to do it. And one that customers have, those companies who have sort of used this and at least used the security as part of the 4 different stages of the application lifecycle, have been 3 times as successful as the customers who don't have any security as part of the early stages of the application pipeline. So I highly recommend everyone to think about it. What are the different stages where you want to have a checks and balance? Think about this as like a manufacturing plant, like a car manufacturing, right? Toyota came up with this very, very early on, whereby somebody in QA, as the car is going through the assembly line, pull the ripcord early on, because the further it goes, and if you have the defect, the harder the problem it is to fix. Security is the same way. Make sure you have a whole bunch of checks and balances, and customers who are able to do it are able to successfully ensure that they're able to move fast, as well as make any mistakes in leaving their cloud infrastructure and application vulnerable to attacks. So super, super critical. I believe we're going to be sharing this presentation as well. There's a link at the bottom. It's got a really good data. It's less marketing. It's more about your own sort of knowledge sake. We did a study in terms of our customers' environment, VMs, containers, what are the typical things we see across different customer segments, et cetera. So depending on, where you are, you should definitely take a look at some of the data to the extent that it's useful for you. So the cloud native DevSecOps, and I talked about some of this thing, but I'm going to go a little bit a step deeper in terms of the solutioning, right? If there is anything I have you leave this specific session with is these 5 things that you should be doing actively, because there's a whole lot of things you can do. Because think about it, like what are the threat vectors in the cloud? It's data, apps, network, cloud infrastructure, identities. What are the security functions? Prevention, visibility, governance, threat detection, and remediation. It's like 5 cross 5. There's like 25 different things you have to do. That's a lot. But these are the basic 5 things that you can start thinking about. First is vulnerability management and image scanning. Like I said, right at the onset of when the developers are building the code, once the code is built, it goes to your source code repo. Make sure you've got a scanner running there, looking for vulnerabilities. If that doesn't work, make sure you're scanning container repo, right? Like ECR, GCR, Docker Hub, whatever the registry you're using. Make sure you've got constant vulnerability scanning, and you should have a very simple, basic policy. Anytime any image with anything, even a single critical vulnerability gets deployed, you want to block that. Just start there. Just start very simple. Because you're going to find that because the developers are using a lot of open source tool and images, you're going to see a lot of vulnerabilities. Let's start prioritizing, start with critical. Nothing with critical vulnerability will ever go into runtime. So that's where you can start. The second big important recommendation I'd make is cloud infrastructure security. So who here uses Terraform actively? Okay, good. CFT, CloudFormation templates? Okay, good. And Azure ARM? Okay, perfect. This is generally the mix we see. Most customers have either Terraform and CFT or some other variation, but obviously, obviously CFT has caught up quite a bit, but I think Terraform, because it's a multi-cloud thing, is still one of the most popular one. Start scanning those. for vulnerabilities or potential misconfiguration risks. That's the easiest thing you can do. You can say, now, by the way, within the ISC, there are multiple problems you're going to find. Database is not encrypted, or security groups not open. What should you prioritize? I'll tell you the biggest threat vector in the cloud, network. It's still the network. The bad guys are still exploiting and trying to figure out a vulnerability within your network infrastructure. So what you should be looking for is any infrastructure element that has public-facing stuff, like somebody wants to spin up an RDS instance, attach a security group with zeros, say no to that. VMs with security group, say no to that. You can let other things slide, because there are like 800 different checks you could do, right? Like, I mean, RDS at-rest encryption is just one of them, but there are like 800 other compliance guardrails. But you got to start somewhere, and I would focus on security groups, basic stuff, attached to VMs, attached to databases, anything that has a networking piece, like S3 bucket. S3 doesn't have, S3 can be part of VPC endpoint, but you can make it public. Just monitor for those. That'll cover 80% of your infrastructure-related mistakes. Number 3, drift detection. So this is a little bit more for advanced customers, which is the idea that I'm not even going to have anybody in the organization have IAM access to the cloud. Just take all the IAM roles away, everything gone. The only thing that can touch your cloud infrastructure are machines and automation, no humans, no nothing, right? In that world, you could imagine a situation where if all I trust is my CI/CD and my immutable infrastructure pipelines, all I need to do is detect drifts. So like I have a gold master state, I did the IAC checks, everything looks perfect, deploy the infrastructure. Now all you're doing is detecting drift, because there's a snapshot of infrastructure that is deployed, and drift is like this security group is supposed to look like this. Oh, it's not. Let me just go ahead and redeploy the entire infrastructure using the thing that I know, the last known good state. Now it's easier said than done. Not every customer has that level of maturity, but that's another big area that you can invest in. This way, you can avoid having to face tens of thousands of alerts in your runtime. Because make no mistakes, if you're not doing any of this stuff, when you just shine a bright light on what's happening in your cloud infrastructure and application security, you're going to find tens of thousands of vulnerabilities and misconfiguration. And typically, customers just completely freeze when they see that. So the way to avoid that is just IAC, detect drifts all day long. Secret scanning is another threat vector. Like, we're seeing this quite a bit. Developers do. I always say, like, developers don't put their access key in a sticky note, right? Like they've got to put it somewhere, right? Ideally, they would encrypt it using key, like vault type infrastructure. But most people in dev and QA don't think about it. They're like, okay, I'm just going to do it. This is the API access key. And as it turns out, that access key and those secrets have a lot of access. It can build the entire infrastructure. It can assume role. It can do all kinds of bad stuff, right? So detect secrets in your public repo. And you'll find that because it is going to help you against identity is another threat vector. Once you identify that, fix that problem. And last but not the least privileged IAM. I talked about it already, but I think this is the 7 out of 10 breaches in last 2 years was because of overly permissive IAM access. And the way this conversation typically goes is most customers start with least privileged access model. Like, you are a DBA or data analyst. You will only get read-write access to RDS instance. Okay, that's how it starts. You're the infrastructure person, you get only EC2 access. But then the DevOps developers are like, I can't do my job, I need more access. Fine, one more access. Well, I got to access it from somewhere else. Fine, I'll give you more. Next time, star. And there is an IAM access key hanging off of that role. Now you have too much IAM access. Now, in spite of your best attempt to protect your workloads against vulnerable images, doing AppSec, doing infrastructure as code security, if your identity is weak, what's the point of any of this stuff? Somebody can get in, and this is what happened with one of the largest banks, where basically somebody detected a secret in a public repo, downloaded that, went to an AWS instance, which was running WAF, Web Application Firewall. From there, they assumed role into another AWS account that had the S3 bucket with all sensitive data. And they were able to exfiltrate that. It was about hundreds of thousands of customers. So starting with least privileged IAM access, I think just constantly monitoring will give you a good ROI in terms of your security investment. So those are the 5 big areas. Really encourage you to think about it. And obviously, these 5 areas need to be across all stages of the pipeline. I've talked about this quite a bit, but in the build stages, do infrastructure as code scanning, image and secret scanning. In the deploy stages, do vulnerability management, scanning your repo, continuous compliance, et cetera. And at the runtime, now you can do network scanning, threat detection kind of stuff, like, hey, do you have a crypto miner? Like, this is where, like, bad things are happening, basically, right? Like, you left your house with windows and doors open. You tried your best to close them. Somebody gets in. Now you want to make sure that you have the detection, the ADP, to detect that somebody just got in, and you can do something about it, right? At runtime, you should be doing web application and API security. So if somebody spins up a web app, there's a SQL injection, cross-site scripting type attack, you need to do it at runtime. And a whole bunch of other stuff, right? Like in runtime, there's no dearth of security controls. A big part of and motivation for this particular talk was to ensure that you understand the importance of shifting left, because that's the only way you're going to be able to move fast and break things, or not. I think this is the only marketing slide I have, and which is about Prisma Cloud or Palo Alto Networks. What have we done in this area? Obviously, we check all of these boxes. Otherwise, I wouldn't be here. But we acquired a company called Bridgecrew. Show of hands if you're familiar with Bridgecrew. OK, good. Show of hand if you're familiar with Prisma Cloud. OK, quite a few of you. OK, fantastic. So yeah, we acquired Bridgecrew because they do IAC, shift left, security. We've got an open source project obviously available. Some of you may already be using it. But now it's obviously integrated as part of Prisma Cloud. We're in early stages. We're in beta. We're going to be launching this in January. So this whole cloud code security as a pillar is going to show up in the platform where we can scan infrastructure as code. And basically, the idea here is that you're going to have a consistent set of policies from build to runtime. So when you say, look for security groups that are highly permissive or S3 buckets that are open, you can write the policy for your build time, which is your infrastructure as code, as well as runtime. Consistent way to look at build and run. That's number one. Obviously, security embedded early on in the life cycle. So we support all major CI/CD plugins, IDEs, VS Code, I mean, you name it. And with Bridgecrew, obviously, support all the different formats as well. Terraform, different variations of CFT, ARM, Kubernetes, YAML files, and so on and so forth, right? So different formats. And obviously, we'd like to think that tool like Prisma Cloud and Bridgecrew can kind of help reduce the friction that exists between sort of the DevOps teams and the security teams. So that's kind of 1 minute talk on what we do and how we have helped. And look, I mean, I've talked about this. These are early days. So if you feel you're a little bit lost in this journey to security infrastructure, you're not alone. Like these are very, very early days. Containers and container security is relatively new. Infrastructure as code is new. All the stuff is new. So a big part of this is just kind of learning as much as you can about it. Reduce your attack, threat vector in the cloud. But the benefits of DevSecOps, and I shouldn't, a lot of you already do this function, so I shouldn't have to tell you, but it's quicker time to remediate, decrease high severity events, simplify compliance, and obviously minimize the attack surface. The one recommendation I'd make, and I think this is my last slide. Let me go back. what is the role of DevOps and security, right? Like, how should you think about this handshake between the two? Let me give you a practical recommendation based on what I've seen, not what's in the slide, et cetera. So the most simplest way I can describe this is that for all risks and vulnerabilities, shift left. For all incidents, shift right. Okay? So that means a centralized security team, by and large, should own a lot of this technology and tool set because they have the expertise, they can write the guardrails, let the developers and DevOps focus on doing what they do best, which is build great applications that's going to bring a whole lot of business for you all, right? Let the security teams write the guardrails. If there is a knowledge gap, maybe have embed models. But anytime they discover problems, risks like vulnerability, infrastructure problems, or misconfiguration, shift left. That means, get them to fix it early, open Jira tickets, et cetera. PagerDuty alerts when there is a problem like security group, like PagerDuty alerts, Slack, wherever developers are, or early on in the CI/CD pipeline. For incidents, like there's a crypto miner, or command and port scan, port sweep, somebody's trying to exfiltrate the data, shift right. This is where you need security experts, your SOC teams. Because if you tell the DevOps, like, hey, there was a crypto miner, they're going to freeze. They won't know what to do with it. Because it will require a lot of advanced investigation. You need XDR-type capability. And your SOC teams, to the extent that you have those, are able to address those more effectively. So that would be my recommendation. It sounds simple. We have had customers who do it really successfully. And another question that I often get from a lot of people is like, what if the developers just don't pay attention to this? Like, security is going to send all this stuff. What if they don't do it? Well, we have had customers who take very extreme measures, like change incentive structure. Like application teams' bonuses are tied to how many security problems they've fixed. Now, that's an extreme case. I don't think anybody, everybody can do it really. But you're going to have to change a way to change the behavior. The one thing I've learned is developers do care about security, more so than an average security professional would like to think. It's just that it's got to be frictionless. Security's got to be where the developers are. So to the extent that you enable them, you're going to see a lot of changes already. So that would be my recommendation. Obviously, we've got a booth at AWS where we can show you the demo. This is all available in the product now. But with that, I'm going to wrap up this session and open it up for Q&A. I know I'm a little early, but we can leave plenty of time for Q&A. Thank you all. Yeah. Do we have a microphone? But yeah, go ahead. I'll repeat it. Don't worry about it. Yeah. Yeah, that's a good question. If you lock your IAM, if you and apply all the preventative controls, lock your IACs, this problem shouldn't happen. Bulk of the time we see the reason for drift is because people do have access to IAM. Once in a while, your automation is not doing what it's supposed to do, and somebody's going to log into the console and make some changes. Because there is a fire, somebody needs to launch an application. That's typically what I've seen. Yeah. Yep, go ahead. Yes. Yeah, so the question was, are you able to add custom rules in IAC? That is correct. Like that's one of the, again, at the cost of talking a little bit about Prisma Cloud, we do allow, we ship out of the box rules policy. So by default, you shouldn't have to do anything. But if you want to write some custom rules, absolutely, you can. Yeah. Any other questions? Yeah, there's a couple of questions this way.
So you mentioned trying to get developers to pay attention to the security issues. My take is it's a capacity issue. And specifically, what do you recommend to do to get product and all of the stakeholders involved to prioritize security issues? Because they just see it as table stakes. Application should work, application should be secure, I want my feature functionality. So what do you recommend to customers to try to get everyone to buy in and properly prioritize the security along with all the market-facing demands as well?
So I don't know why it was just me, but I couldn't hear the question completely. But I think, was your question, what are some other techniques I would recommend for developers to get more buy-in on using security? Is that roughly what it was?
Thanks to Mike.
Maybe it was the mask, I don't know. Yeah.
The speakers are pointing this way. How do you get product to buy in so the developers are busy adding the feature functionality that product is prioritizing and demanding? So, and the product team tends to think of a running application and a secure application as just table stakes should be given, and they don't really recognize the amount of work it takes to make both of those things actually happen. So how do you get all the stakeholders to buy in and prioritize the security tickets?
Yeah. The best customers, the way they do this is kind of the trust but verify type model. And the way it works is that you're going to enable them. So first of all, security should see their role as enabler in today's day and age. Like the idea that those guys and gals, like I don't know what they're doing, they're building stuff, like I don't know, it's going to break stuff. Instead of that, like you got to embrace them, figure out like where they are, like I repeatedly said. But the verify part of this is like monthly review. So like obviously products like Prisma Cloud has, stuff by business units and application. Like you can just say like, hey, these are the number of vulnerabilities you have. It's a PDF report, it's an email, whatever you have. I think if you have those reviews and checks and balances and talk to the head of products and say, hey, like your teams have not addressed it, I think the behaviors will change. We at Palo Alto Networks, I mean, obviously I have to worry about our own product security. We regularly do security reviews. I mean, and it's not an optional thing. So, no magic wand. The only key word is easy, frictionless. If you're going to deploy a piece of software like a Defender on a VM and asking or on a container or Docker daemon, make sure it's not going to hog up the CPU where application goes down. You'll have one shot. It's over after that, right? So frictionless, doing it early, doing periodic review. But trust me, I talked to like 10 customers already in last 2 days. This problem has not been solved. There is still a lot of this back and forth going on. Sometimes DevSecOps says like, hell with this, we're going to completely take ownership of this. But I think treating this as a partnership enablement, which by the way, every security team I know is now treating this as a partnership. It's just that the roles and responsibility checks and balances are still a little bit all over the place. But good question, yeah. It's top of mind for a lot of customers. Yeah. 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 Yeah, I mean, it's, as you were asking, I was thinking deeply because this is like, a lot of the questions I'm hearing is less about technology and more about psychology. Like how do you change human behavior and get people to understand it? And look, I mean, I wish I can tell you we've cracked the code on this one. Like, we're the tool and technology provider. But I was talking to customers that they have an elaborate document on exception process. But I'm like, in today's day and age, like creating a 30-page PDF on exception process, is that even going to work? Like nobody cares. Look, I think my only recommendation is same as before, periodic reviews with them. But hold the line on few things, which is, again, like I can't tell you more. Identity and network represents your biggest threat vector. Don't pester them with, I don't have at-rest encryption turned on, this, that, and the other, 100 vulnerabilities. Start with like a simple thing. Hey, I want you to fix this 10 thing. Open a Jira ticket for them that says, these 10 vulnerabilities that I have identified based on my, can you prioritize that in your next sprint? Okay? I think if you, I'm yet to talk to a developer who says, I don't care about security. It's just that a lot of times, hey, log into the security tool that I just bought for whatever and figure out like how to fix it. That's just not gonna work. Tell them 5, 10 things to fix. Once they do it, the psychology changes, they understand that they're fixing it, and then so on and so forth. So, it's a good question, but, a little bit more about psychology, but prioritize for them. I think that would be my main recommendation.
Back here.
Is there more? Yeah.
Okay. What vulnerability remediation or incident response frameworks will you recommend? Most of the frameworks I'm familiar with take advantage or leverage the old school waterfall application development, cycles where you have the luxury of having like a test or dev environment that's is close to prod, so you don't have, you can leave prod alone, and you can go and look for your bugs and fix them before you integrate back into prod your code. Whereas in DevOps, the whole idea is to get that software development cycle moving real fast, and you don't have the luxury in some cases of shutting down the pipeline to fix your bugs.
Yeah.
What do you recommend? I mean, what frameworks?
I think, again, like just to, and you can keep the mic so I can repeat the question. So I think, is your question, a lot of times you don't have the luxury to shut down an instance at runtime or halt your pipeline. What do you do in those cases, right?
I'm on the operation side, okay, but I know that there's strong resistance from the application folks and management, to stop to take a product a service offline. But we do have maintenance windows.
Yeah.
For that.
And your question was, sorry, I didn't get the.
Yeah, what frameworks will you recommend, or that will integrate nicely with a DevOps frameworks for vulnerability remediation, incident response or incident response?
Oh, got it. Yeah, look, I mean, NIST CSF has been one of my favorite frameworks, at least from a cybersecurity standpoint. So I always tell the customers, like, where do I start, where do I end? So I have a very simple variation of NIST CSF, really. What are your threat vectors? Identity, data, applications, cloud infrastructure, and workload, right? And network. 5. And in the CSF framework, what are the security controls you need? Prevention, visibility, governance, detection, and response, right? So visibility and cloud infrastructure security, you need infrastructure as code security, check that box, right? That way, if you use like this 5x5 grid, and maybe I should have had a slide built, you can check different boxes. Do you have a preventative control to secure your cloud infrastructure? Yes, if you're doing IAC scanning. Do you have preventative control for your workload security? If you're doing repo scanning, check that box. You go further down, detection, which is, hey, like my prevention controls didn't work. Do I have detection? Well, yeah, you need to scan your runtime for misconfiguration, check that box. I need to check my runtime for potentially bad containers with known vulnerability, check that box. So that's probably one way you can start looking at different frameworks across NIST CSF continuum. And again, my recommendation would be start with preventative control. In security, frictionless preventative control are your best tool. Any prevention technology where you got to route all the traffic somewhere, like network security, I don't recommend prevention from the perspective of like, hey, like route everything through firewall. Although, I mean, I'd love for us, Palo Alto, to sell more and more firewall, but it's just not practical in cloud workload, right? So hopefully that answers your question. Yeah, okay, great. What else? Okay, I've got a couple, 3 air tags to give, so I do have, I'm just gonna have to make up a couple questions. Whoever answers gets that. Who can name all the different, who can name 5 infrastructure as code formats or frameworks? What are the different names? All right? Yep. And did you say GDM as well? Google Deployment Manager? Or you, oh, that's fine. You're good. Here. Ah, good catch. Okay. What's the, I guess let me ask you another question. Anybody knows what SCA stands for? From securing, so the hint is it's an acronym for something where you secure your open source libraries and other stuff. SCA acronym. SCA. Okay? Sorry? Static code analysis. It's software composition analysis, but it was close enough. Here you go. We got, okay. I will, okay, good catch. I've got a third question. Okay. What does SAST stand for? SAST, S-A-S-T. Not S-A-A-S, SAST. It's a security thing. This is a security talk, Ops, AppSec. Okay, all right, okay. All right, perfect. All right. Okay, thank you all so very much. I know you had to, given the emergence of new virus, you had to take a lot of time to make, but I'm glad you came, and hopefully you learned something from this session. I really enjoyed the conversation. Thank you all.